Calculus, Unit 5, Day 44 notes. We're still dealing with particle motion, looking at net and total distance of a moving particle. And we're on part 3. So part 3 says the position of a particle is given by the function P of t equals e to the 2t minus 8t, where P of t is measured in feet. Find the net and total distance the particle travels from zero point 0.5 minutes to 1.5 minutes. So as I do this one, I'm going to find net distance by uh, trying to find out P of A minus P of B and taking the absolute value of that. So it's from 0.5 minutes to 1.5 minutes. So just put in 0.5 into our function, get a value, put in 1.5, take the difference, then take the absolute value. I'll give you a couple seconds to do that. You should get 9.367 feet. Okay, next we want to find the total distance. So I got to look, hey, the total distance is first going to be determined whether or not it's if it's always moving right or always moving left, then the net distance and total distance are going to be the same. But so let's take the derivative of this. So the derivative of this is e to the 2t times 2 minus 8. And hey, let's just rewrite this as 2e to the 2t minus 8. Now I could use a calculator and find out if it's always positive, always negative, or where it switches. Or I can um, find where it's 0 or undefined for my critical values. And first of all, I know I'm looking on the interval from zero point 0.5 to 1.5. So see if I can find any zeros here. And let's do that. So I'm finding out where it's 0. So I'm first going to add 8 to both sides. Equals 8. Then I'm going to divide by 2. Equals 4. Now we're going to take the natural log of both sides. And I know when I do the natural log of both sides, and let me just get a different marker here, I can uh, powers properties of the log, so I can be 2t, natural log of e is just 1, 2t equals natural log of 4, t equals natural log of 4, all divided by 2, and let's get that value using the calculator. And natural log of 4, and then divide that answer by 2, and I get 0.693. So on my sign change chart, let's go to that. So 0.693 is like over here, 0.693. That's the only value that's going to make this go to 0. So now I got to pick something between zero point 0.5 and 0.693, put that value in, and when I do that, I find out, and let's see what that is. Let's put um, zero point 0.6 in there. So I do e to the 0.6, that's going to be a number smaller than 2.7, times 2 is going to be smaller than 8. So that's going to make this, and I should say t instead of x. That's going to make this negative. And now let's pick 1. E to the 2.7 is going to be e squared, which that's going to be 2.718 squared. It's going to be a number bigger than 4. Times 2 is going to be bigger than 8. And then minus 8 is going to be positive. And again, that's t equals 1. So it changes directions. So now that I see that it changes directions at 0.693, I got to do a little work here. Okay, so here's my formula. So when I go from 0.5 to 0.693, I'm going to the left. So I'm going to find the distance, the net distance there, get a value. Then I'm going to add that from when I stop going left and I start going right. I go from 0.693 seconds to 1.5 seconds. I'm going to be traveling to the right, and I'm going to find that distance. And then I add them both together, and we are going to get a value of 9.894 feet. So just check that out, and we can, before we do the two problems at the end, we can look at how to do that on the calculator as well. Okay? But you're going back into our original function, P of t, to find out what the total distance was. And that's what we do, the net distance. Okay? But I had to check, since there was a value that um, went to 0, meaning there's a chance 0 undefined means it could possibly change directions. All right, next problem here. The position of a particle is given by the function P of t equals t plus 2 sine t, where P of t is measured in feet. Find the net and total distance the particle travels from t equals pi over 6 minutes to t equals 5 pi over 4 minutes. Well, I know the net distance is always the same. Net distance is always equal to the absolute value of the difference of P of A minus P of B. And now, so I put those values into my original function, P of T, and so I got to put P of pi over 6 in there, get a number, and then 5 pi over 4 in there and get a value, and then take the difference and then take the absolute value of that. So why don't you take 30 seconds to do that and check your answer with my answer. Okay, and you should get 0.989 feet. Right now we got to know total distance. So the first thing I need to check is, does it change directions? And there's only a chance of it changing directions if I get a 0. Because if it's never equal to 0, if it's always positive, then it's always going to the right. If it's always negative, it's always going to the left. But whenever it gets to 0, then there's a chance of it changing direction. So let's check. So the first thing I need to do is take the derivative. The derivative is going to be equal to the velocity function. So the derivative of t is 1. Derivative of 2 sine t is 2 cosine t. And now I want to find out where that equals 0. 2 cosine t is equal to negative 1. We're trying to find where cosine t is equal to negative 1 half. And I want to then do, hey, t equals inverse cosine of negative 1 half, which tells me I'm going to be in either the second or third quadrant. Um, and let's see what I get here. I am going to end up, oh, well, actually, I got to be between pi over 6 and 5 pi over 4. So that's going to be the second quadrant. 1 half. Just draw myself a quick triangle here. So 30, 60, 90 triangle. 1 to 2 to square root of 3. So I'm dealing with the 30 degree because, oh, cosine, never mind. I'm dealing with the 60 degree angle. So there's 60. There's 60. So that's going to be 120 degrees. Well, if 60 is pi over 3, then this is 2 pi over 3. So t equals 2 pi over 3. Okay? So now we could do a sign change chart, and I could also do this on the calculator. So I know I'm going from pi over 6 to 5 pi over 4, and 2 pi over 3, which if we did that on the calculator and got decimals, 2.904. So it's 2.904. That's going to be the 0 of this velocity function, which is the derivative of the position function. Okay, so now I want to see if it changes directions. And when I put in 2.094 or 2 pi over 3, so first of all, I know 2.9, and that's going to be, sine's going to be positive, so 2.9 plus 2 times a positive is going to be positive. So here it's going to be positive anywhere in there if I put in 2. And then, like if I picked a value here or here, let's pick something past there. 5 pi over 4 ends up being, what, 225? So I can go all the way to there, but let's see what that is. If that's where my, I'm doing it via t. Oops, sorry, I did sine. I should have done cosine. So let's do that again here. Um, let's start again. Okay, let's check that again, this time using v of t. I was using the original function. So what I did is I just quickly graphed it, and I made each interval here. Let me show you the window. I went from 0 to 10 on the x, and then with a scale of 0.5, and then I went negative 3 to 3 on the y. So let's go back to the graph. So I start at pi over 6, which 3.14 divided by 6 is roughly 0.5. So I'm kind of roughly starting right about here, excuse me. So I see it's positive all the way up until where I get to this 2.0954. And then 3.14 divided by 7 is Um, 3.14, the 5 pi over 4 is going to be somewhere in the, let's just 2 that out, just to get an exact number, 5 pi divided by 4. Hey, that's 3.9, so that's almost 4. So let's go back to our graph. So 0.51, 2, 3, 4. So it hasn't gone past there. So this is my 2.904. So I see in it, so it comes out to the same answer that I had down, but I didn't do it the correct way. So let's go back to my sign change chart, and let's just look at what that means. So hey, it's positive here, and then from here, the derivative is negative. Okay, so and again, you could have done that with a calculator using these values. Pick any number less than 2.904 and pick any number greater than 2.904 as long as it's on the interval. All that tells me is that I changed direction, so I have to use my, to find the total distance, I have to do absolute value of the position value of p over pi minus 6 um, minus my p of 2 pi over 3, or I'll write it as 2.904. And either way, whatever I do there, so I'm going to go back and use my calculator, and I'm going to add that to when it was traveling from that value of the position 2.904, and then take the difference to find out how much it traveled and when it was going to the left, 5 pi over 4. Get those two values, and that's going to give us our total distance. I'll pause it and give you 10 seconds to see if your answer matches up with my answer. Okay, and I get 3.617 feet. All right, these next two problems we'll do right at the beginning of the class. So if you want to do them now, check them out. That's fine. But continue working on the homeworks, and we'll have some time in class to do that as well. So this was part 3 of the day 44 notes. Thank you. Thank you.